Okay, in this related rates problem here, I'm going to just try to describe it. I'm not going to try to write it all out. And I don't think there's one on the homework that's like this. This is probably, I would say, the most challenging one. And it does bring out some other things. So let me describe kind of what's going on. So you have a light here. This is like some light shining. You know, it's shining out. And this light is 50 feet tall. Okay, and it's shining down on the ground. Okay, now about 30 feet away, you know, starting at the same height, you drop a ball. And so this ball is going down, right? And so you have like the height of the ball at time t. And in fact, we know h of t because this is, you know, the acceleration due to gravity type problem. So this would be the function of that. Okay? And now notice here, if this light is shining down, let's say the ball is like right at this point. If the light is shining down like this, it casts a shadow right here, right? It would be like right here. If the light were like if the ball were like right here, then this light would shine down, and it would cast a shadow right here. You know, if it was halfway, like right here, the light would shine down, and it would cast the shadow right here. So this ball, the shadow here, right, is moving kind of right towards this point, and when it hits the ground, that's when it'll reach that point. And so let's call this distance here x of t, right? X at time t. So here's the height, here's x, and you can see that x is like moving this way. It's decreasing, right? It's getting smaller from here to here. And it wants you to find dx dt a half a second, half second after it's dropped, after ball is dropped. So a half a second later, it wants to know how fast this shadow is moving in. Okay? So, some important things here. This is 30 feet away, okay? And so the distance from here to here would be like 30 plus whatever the x is, right? Okay? Now, for any one of these, like for this triangle, see if you have this triangle here, you would have two similar triangles where you would have 50 is to this length, 50 is to this length as the height is to the x length, right? And it doesn't matter where you're at. So like for this triangle here, you would still have 50 is to this length as the height is to the x length. Okay? And let me see if I can write this down here. That's a proportion, and it involves similar triangles. Whenever you have like a triangle, and then this line is parallel with the base, then the overall triangle is proportional to the tip here, to this little triangle. And so I would have 50 is to this length, like 50 is to this, and what this length is the 30 plus the x. So I'll just write 30 plus x. I won't write x of t. Okay? So 50 is to this as the height of the ball is to this. And so that would just be h is to x. So 50 is to this whole length as the height of the ball is to just x. And I'm going to just write it like this, not in terms of the function notation. Okay? And and it wants us to find this. So before I try to figure out what I need here, let me take the derivative of both sides of this. and see if I can solve for dx dt or whatever. And I think to simplify this, because I would have like a quotient rule here. So to simplify this, I'm going to cross multiply, and I'd have 50x is equal to h times 30 plus x. Okay, and then I'll distribute that 30. I'm sorry, I'll distribute the h. So 50x is equal to 30h plus xh. And now what I'm going to do is I'm going to take the derivative of both sides with respect to t. So this side would just be 50 dx dt. And this side, well, this would be 30 dh dt. And then this piece here, I would need to use a product rule, because we have like x of t and h of t. So I would have dx dt times h plus x times dh dt. Okay? And what I want is I want the dx dt on one side and everything else on the other side. And so what I'm going to do is I'm going to move that dx dt over here, 50 dx dt, and moving that over I get minus dx dt h, and this is equal to 30 dh dt plus x dh dt. Okay, and I've done this already, so you wouldn't have known how to simplify this, but I think what'll be nice is I'm going to factor these out. So this would be like dx dt, and I'd have like 50 minus h. And then here, I'm going to have a 30 plus x dh dt on the outside, right? And then I can divide both sides by the 50 minus h. So I get dx dt is equal to, I got like 30 plus x over 50 minus h dh dt. Okay, so now let's think about what we want. What we want is we want dx dt when t is like a half second, right? So what are the things that I need? I need to know what x is after half a second. I need to know what the height is after half a second, and I need to know what the derivative dh dt is after half a second. Well, the height, that's easy because I can just put in h 1/2, and I get negative 16 1/2 squared plus 50. Well, this would be 1/4, so this would be negative 4 plus 50, and so that would be 46. Okay, well, the dh dt isn't too bad either, because I just take the derivative of this, and I get negative 32, and this is negative 16t squared, of course. This would be negative 32t, right? And so after half a second, that's easy. Just plug in a half a second here, and I get negative 16. Okay, and that's the dh dt. So now all I need to know is what the x is, right? So we're going to use the similar triangles for that. So I got this, right? And if my height is well, this is 50, and then this is like the height, and the height here is 46. So this height is equal to 46, and then this is 30, and this is x. Okay, so what I have here is the following. I'll write it up here. I have 50 is to 30 plus x as 46 is to x. And so then I need to solve this. So I have like 50x is equal to 46 times 30 plus x. So I get 50x is equal to, and I'm trying to just squeeze it in down there in the corner. So 50x is equal to 46 times 30. 46 times 30 is like 1,308, or 380. And then this would be plus 46x. And so then bringing the 46x over, I get 4x is equal to 1,380. And then I can solve for x by dividing that by 4. And this is like 345. Okay, so now I have all the things I need. I have the height is 46. The dh dt is negative 16. And this is the x. So now we can plug these in. So this would be 30 plus 345 over 50 minus 46, and then all of that times dh dt, which is negative 16. Okay, so 30 plus 345 is 375. I divide that by 4. I get like 93.75. Multiply that by negative 16, and I get a negative 1,500 feet per second, or per second. And so, which is the right answer, but it's also very, very surprising that it's so fast at that point after half a second. Boy, that shadow is moving very, very quickly. Let's see what it is in miles per hour. Maybe it's not as quickly as I think. Let's see what it is in miles per hour. So that's feet per second, right? So that would be times 60 for minutes, and then 60 for hours, and then divide that by 5,280. Yeah, so about 1,000 miles per hour, according to that. So that's very, very surprising. But also a very interesting problem, one that involves some other stuff in actual function in terms of t, involves similar triangles. This is not an easy problem. It took me a while to figure it out, but I was able to do it. Of course, I've been doing it for a while, but that is a neat problem. That is a very cool problem, and for now, I think we'll end there, and you can work on the related rates homework, and please let me know if you have any questions.